Okay, so today we are going to talk about sigma notation, this symbol. You must have seen this in your exam many times, and this might look scary, but this is just a simple notation that we use to simply write a very bit sequence or a series. Yeah, as we go through the chapter, we will see this is nothing more than just a way of writing a big series in a small notation. Okay. So whenever you see this, you need to remember that whatever the question is going to be about, it's going to be about summing up a series. Okay, so now we will understand how we can use this sigma, how we can understand this sigma notation, what the questions in the exam will look like, and how we will go about solving them. We have all of these formulas which we have seen in the previous videos for arithmetic and geometric sequences and series. We know how we can take a sum about that and how we can have a generalized formula for each term. Okay, so now we have a series here. What do you think? What type of series is this? Okay. What type of series do you guys think this is? Between here and here, what is the difference? Between here and between here and here, between here and here, and between here and here. If we look at all of these terms, you will realize the difference is always 2. Here also it is 2. Okay, so the difference each time is 2. It's 2, right? So this is a arithmetic series, and for arithmetic series, what our t of n is? For arithmetic series, the t of n is a plus n minus 1 d. Now we already know the value of d is going to be 2 and our a is 2. Then our formula will become 2, n will be n and d will be 2. This will be t of n will be 2n minus 1 multiplied by 2. And now when we will open the bracket, when we will multiply 2 by 2n and minus 1, and minus 2 will cancel out with plus 2. Minus 2 and plus 2 will be cancelled out. Minus 2 and plus 2 will be cancelled out. And then we will be left with this, and this will cancel out. And then we will be left with the general formula, which will be two of n. So the general formula for this sequence will be 2 of n. Okay. Now, how do we write this using sigma notation? The whole point of this sigma notation is when we have a generalized formula, we don't have to write out the whole series one term by after another term after another term. And we will just use this notation to represent that. Let's see how we can write that. Now, we can use n, and in the same way, we can also use k. Because this is just a arbitrary variable. Arbitrary, what I mean by that is this is just a placeholder variable that we use to represent any term at any point in a sequence or a series. Here we can denote it by k. It will also work if you denote it by n. We say for the value of n is equal to 1 or k is equal to 1, the first value is 2. And our generalized formula will come here. This will be 2k. We will replace n by k, of course, because we are using k as our arbitrary variable. And here we will write the last term of this series that we are going to use. Okay. So this is k is equal to 5 is the, till what point are we going to add it? Okay. and we start from k is equal to 1. From which point in this series do we start adding? Do we start adding from 0? Do we start adding from 2? And to up to which term do we go? Because for this 10, what is my 10 going to be? My 10 is equal to 2n, right? And when I have that, what will happen is my value of n is equal to 10 by 2, right? And then my n is equal to 5. So I know I have to stop at the fifth term. And this is exactly what we have written here. We start with the k is equal to 1 and we end at 5. And 2k, what is this 2k? 2k represents the generalized formula of our sequence. And what does this represent? So this basically just says this given term just tells us that start adding 2k from k is equal to 1 and end it when k is equal to 5. Okay. Now we can have the same thing for a geometric sequence or a series also, and for any generalized terms in terms of position. Here we were using k, we can use n also. For in this case the generalized term is n square. So what this notation represents? It represents that we will start filling the value of n from 3 and we will go up to 6, and then we sum all of it up, which is going to be 3 square plus 4 square plus 5 square plus 6 square, which is equal to 86. Sigma notation only tells us three things. If you want to understand it very simply and just put it in our mind, just think about it again. What does the sigma notation tells us? It tells us three things. What to add, which is our generalized term, from where to add, which is our first term, and up to which point we should add, to where. So it tells us what to add, from where to where, and that is our sigma notation. Okay. Okay. Now we are going to see how do we read the formula and how do we properly utilize it in the questions. Okay. So this is what generally you will see in many questions or in many tests that you have been given, and you are expected to understand this very intuitively. So okay, here we have a generalized summation notation. So what this is representing is that for this series we have to substitute the value of k is equal to 1 and take it up to k is equal to 3. Okay, so let's do that here. Let's substitute the value of k1, let's substitute the value of k2, and let's substitute the value of k3. This is k1, k2 and k3, right? k1, k2 and k3, right? This is what our terms look like. And let's add this up. This will be 9, of course. So how do we read this again? Top is the last substitution. The top number is going to be our last substitution. The formula is the generalized formula for the end term, which is represented here. And then we have the last term, bottom term. Okay, so here is your generalized formula. Here is your top term. Here is your top term. And here is your bottom term. Okay, these are the three places where you will have values. Okay, so now using this, let's say right now how many terms were there when we substituted the value of 1, 2 and 3? There were three terms, right? 1, 2 and 3. And if we want to find out the number of terms that a given summation notation is asking us to calculate, what we do is we take the last substitution and we subtract the first substitution, the bottom substitution from it, and then we add 1. Okay, because this represents the last number and then we add 1 because we have subtracted the first term from it. Okay, so this is our generalized formula for anything, for anything that has any summation notation that has values going from one given term to the last term. The number of terms are going to be given by top minus bottom plus 1. Okay, for example, this is a sequence or this is a series that has been given to us. For this, how many values of n will be there? We will use n minus 3, minus 2, minus 1, 0, 1 and 2. Okay, so how many are there? It is 1, 2, 3, 4, 5 and 6. We have 6 terms in this, right? We have 6 terms in this. And how do we find the terms? We can just use the formula top 2 minus of 3 plus 1, which is 6. This is exactly the same. So we know that our formula works for this. Okay. We have another example where the series is given to us like this. The value of k or n is minus 2 to 5. So what are all the values of k that we will substitute? These are going to be minus 2, minus 1, 0, 1, 2, 3, 4 and 5. And if we find out the number of terms, it is going to be 5 minus of 2 plus 1 and is equal to 8. Okay. How do we evaluate summations for a arithmetic or geometric series? Now this was the general introduction where we discussed what a summation notation represents, how do we read it, how do we understand it. It has generally 3 parts, which is the top part, it has the bottom part, and it has the term, which is the generalized formula, right? This is what we studied by now. Now we will go ahead and we will read and study what happens when a arithmetic or geometric series is given to us in a summation notation. Okay. Now we have to calculate the value of summation from n is equal to minus 4 to 20, and the generalized form term is given to us here. Okay. So when you look at this question, the summation represents nothing but the first and the last substitution value. What we will substitute in the first and the last term. But we already have the formulas here. And if you are having trouble understanding what type of sequence or series it is, we can write out some of the terms. Let's substitute minus 4 into this. Let's take the value of minus 4 and substitute it into this formula. Okay. When we substitute minus 4, we will get 5 multiplied by minus 4 minus 2. Let's substitute minus 3 then. Let's substitute minus 3. So the value of my n is equal to be minus 4 minus 3 minus 2 minus 2 minus 1 and so on up till 20, right? These are all the values of n that I will substitute. Let me substitute 2 or 3 values and then let's see. Okay, let's substitute minus 4, minus 3, minus 2, and then we can substitute directly 20. Okay, so what will this sequence will look like? The value of this is going to be minus 22, 17, minus 12 and 9, T8. So these are my terms. And now when I look at them, what do you feel like is the what do you feel like? What type of sequence or series is this? This from here till here from here till here, what is the common pattern here? What is the, if I sub if I take minus 17 and I subtract 22 from it, then my common term is going to be minus 5, right? Then my common difference, sorry, is going to be 5, right? This series is getting increased. So my common difference is 5, right? So this is our arithmetic series. My a is minus 22. My last term is 98. And my n is 20. How do I find my n? How do I find my n? My n is going to be my number of terms, number of terms is going to be top minus bottom. Top value is 20, bottom value is minus 4. So we will use minus 4 here. And we will add 1. So the number of terms is going to be 25. There are 25 terms in this series. Okay, then S of 25. Now we know this formula. Okay, we know the value of A, we know the value of L, and we know the value of D, which is 5. So we don't even need the value of D because we are going to use the formula where we don't need the value of D. So if you remember this formula represents sum of a arithmetic series when the last term is given to us. So we can directly substitute it. Number of terms is 25. 25 by 2, a is minus 22 plus 98, which gives us 76. And then we can find the sum directly, which is 950. So this is the type of question that is expected of you. There is nothing new here. We already knew the formula of S of n in terms of arithmetic sequences. The only thing that is new is a different way of representing the sum. This is just a sum of this series. Before, in the questions, the series was given to us like this, right? Before, when we were doing question, question used to give us this. But now the question will represent this in this manner. And using this, we will deduce what type of series it is. And then we will find out then we will think which formula should we apply in order to find the final sum of it. Okay. Now we are going to look at another type of question. In this question, it has been given to us that we have to evaluate the sum of this given series up till infinity. This is the sign of infinity. The first term is n is equal to 1 and the last term is infinite. So in this, how many terms are going to be? Infinite, right? Because it's infinitely big number. If we take the top number and we subtract anything from it, it will still be infinite. So we have infinite number of sums in this. Okay, so when I hear infinite sums, I immediately think of geometric series. We can still write it down and confirm the assumption, but I still immediately think that this represents a geometric series. Okay, so for the first term, the value of n is going to be 0, so the term is going to be 3. And let's substitute more values. Let's substitute n is equal to 2, then 3, 1 by 2 power 1. Then we can substitute n is equal to 3 and so on, so on, so on. So this will be our geometric series. And now you can immediately see that your common ratio is, 1 by 2, right? The common ratio is 1 by 2. Between this and this and between this and this, the common ratio is 1 by 2, right? Okay. So my a is 3 and my common ratio is 1 by 2. Okay. So when I have this common ratio and this given to me, now I can easily calculate what my S of infinity is going to look like. s of infinity, in case when r is minus 1 to 1, we need to pay attention that the r needs to be between minus 1 to 1, which in our case is. So in that case, the sum of infinity is a divided by 1 minus r. Okay, so we are going to do that. Okay, the value of a is 3, the value of r is 1 by 2. We will do r minus 1 by 2, and we will just solve this. So the summation series is 6. Okay, so all this question expected of us, on top of recognizing that this is a geometric series, is understanding how the R infinite formula should be applied to it. So we need to be very clear in our understanding of infinite sums in case of geometric series, and then we have to deduce from this notation that, okay, is this arithmetic series or is this a geometric series? There is nothing scary about it. We know the number of terms, and then we just have to look at these formulas and think which formula do we apply to get the final result. Okay, so now we are going to look at working backwards and how do we solve it for n. So the question will tell us that here is a series given to us that is represented by this, and we have to represent this in sigma notation. Okay, when we look at this series, we have to figure out, is this arithmetic series, geometric series, or something else completely different? Okay, so what we can do is we can try to look at the sum between the terms. Okay, what does the sum between the terms look like? So between the first two terms it's 3, then the sum between the next two terms is 5, then the sum is 7, and then the sum is 9. So the sum itself is getting increased. That means this is a different type of series. This is not a arithmetic or a geometric series. When you have a question like this where you cannot match it to a pattern where it's a arithmetic or geometric series, what you have to do is look for generalized terms. Okay, so here I see my first term is 1. Okay, my first term is 1, and then I have 4, then I have 9. When I look at these numbers, when I look at 9, 16, 25, can I realize that this is a square? Every number in this series is a perfect square, right? I want you guys to think about it, that how all of these numbers are perfect squares and how we can use it to find a general term that represents any of these numbers in this given series using a generalized formula. Because these are squares and on each position it's the square of what position it is. This is the first position, and then we have the second position, then we have the third position, then we have the fourth position, then we have the fifth position, and so on. And each one is a square of that. So can I say my t of n is going to be n into n, which is n square? Yeah. So this is my t of n. Okay. You see, we can write it as 1 square, 2 square, 3 square, so on, and 7 square. Then my t of n is going to be n square. How do I write this in the sigma notation now? What is my first term? What is my first term? Okay, let's pull a sigma sign from here. We go here. In this, on the bottom, we will write here, what is my first term? What is my first value of n? I already know my t of n is equal to n square, right here. My t of n is equal to n square. T of n is equal to n into n, right? So I know here this will be n square. And on the top and the bottom, what values will I fill in? Where does the value start and where does the value end? What is the value of n for the first term and what is the value of n for the last term? right? So which is n is equal to 1 to 7 and t of n is n square. That's it. That's our final answer. Okay. Now we are going to look at another type of question, which is determine the value of n if this is equal to 61640. Okay. So now what has been given to us? It has been given to us that there is a series in which the sum is equal to 1640. This could be a arithmetic series or a geometric series, and it has been told to us that when we sum up all the terms of this series, the results comes out to be 1640, and based on that we have to find the number of terms when we start from 1. When we start from 1 as our first value, we have to determine the number of terms which equal to 1640. Okay, so let's first do what we do every time. We write this out. So we use different values of r. We will substitute r is equal to 1, r is equal to 2, r is equal to 3, r is equal to 4, on and on and on. And then we will see what type of pattern can we come up with. Okay, let's do this. Let's 3, value of 3 minus 2 will be 2, 9 by 2, and so on and so forth. And the value will be 1640. Now when we look at this, what do you think what do you think which type of series or sequence it is? We know that how do we find the common ratio? The common ratio is found by dividing these two terms, right? We have to divide these two terms. So in this case, we have a geometric series. Each next term is getting multiplied by 3. It's 1 by 2 multiplied by 3, 3 by 2 multiplied by 3, and so on and so forth. And this formula also represents the same. If I can compare this to a formula like this, if I compare this to a formula like this, I can easily see that the value of a is 1 by 2 and the value of r is 3. And this just represents n minus 1 is just written as r. Just like we used k or n or something to represent it, now we are using r to represent here the common ratio. That's why maybe this formula looks confusing, but these are just general terms which you can use. But if we compare it, then the value of r is 3 and my n in this case is just written as r. Okay, so this is a geometric series with a minus 1 by 2 and my r is equal to 3, and s of n is going to be 1640. Now that we have all of these values, what do we need to find? Because the r is greater than 1, we will have to use this formula, right? We will have to use the formula which represents Sn where r is greater than 1, and this will have a fixed number of terms, not infinite terms. Okay, let's go ahead and let's solve this. Let's put Sn is equal to the formula for geometric series, and then we can substitute it. The value of a is 1 by 2, 1 minus r is 3, the value of n will remain as n, and this will be 1 minus r, which is equal to 1640. When we solve it further, we get this, and then we get that the value of 3n is equal to, we will send the 1 here to be added, 6561. And you can use a calculator to find out what power of 3 will represent this power of 8. 3 to the power of 8 will represent 36561. Then in that case, the n is going to be 8. So how many terms we have in this series? We have 8 terms. We had to find the value of n, which also represents what is the last value that we are going to substitute. One last type of question that we might see is we have to find the value of n when the given term is this. The last question was geometric series, because when we substituted the different values of n into it, and then we found out what the value of is. What the type of series do we have at our hand? Okay, so here we have to substitute the value of n as n, okay, n right now represents the last term for which this sequence will change. The values of k is going to be substituted as 1, 2, 3, so on and so on forth. Okay, when we substitute this, let's see what the terms are. When we substitute n is equal to 1, the term is minus 12, minus 9, minus 6, and so on. What type of series is this? What type of series is this? What type of series is this? When I subtract minus 9 minus 5, the sum is 5, right? The sum is 3, sorry. Sum is 3, right? Every time we have the difference of 3 between here and here. Both places the difference is 3, right? So then we go ahead, we figure out that this is arithmetic series where a is equal to where a is equal to minus 12 and the difference is 3. So this is our series, and then we will use this formula. You will use the formula of S of n to fill in these values. In the S of n formula, we will just fill these values. We'll fill the values in this formula using these, right? And when we do that, the n by 2, 2a becomes minus 12 and the d becomes 3. And we know the summation is equal to 285. And then when we do that, when we multiply all the terms, we get an equation like this. So the equation becomes like this. We can divide everything by 3 and then we will get an equation like this. Okay. So for this, what are the values of n that will, when we add them together, will result in minus 9, and when we multiply them together, it will result in minus 190. So we can say here that x plus y equal to minus 9 and x and y multiplied by y should equal to 190. So what comes to my mind is the value of, there will be two solutions to this, is 19 and 10, minus 19 and 10. So both of these will be equal to 0. This, we know this by solving a quadratic equation. It will have two solutions. The x n can be equal to 19 and n can be equal to minus 10, because in this the first value of k is 1 and n represents the number of terms we will have. N will represent how many terms we will have, and n represents the last term. This value cannot be negative. It should be a natural number. So we ignore the value of minus 10 and we say the final answer is 90. N is equal to 19 is the final answer. So generally the trick is you have to substitute the values in each of the series. Whenever we get a series or a sequence, we have to substitute the value of the into the general terms, and then we have to write down the series. We have to look what type of series or sequence it is, whether it's a quadratic series or whether it's arithmetic series or a geometric series, and then if it is not any of those, then is there a simpler generalized formula that I can write for it, and then based on that we determine what is the first term, what is the last term, and we put it into the sigma notation, and we use all of this information along with the formulas for the sums We have formulas which represent the sum of everything, and we use these formulas to find out the sum for a geometric or arithmetic series, and then we solve the question. Okay, so the biggest trick is you need to find out the value of a and d and interpret the sigma notation in a proper way. Okay, that's it.